In this example, we're analyzing the circuit that is drawn there, and we're asked, what's the power that this circuit draws? Well, in order to answer this question, we're going to have to determine the current that runs through the circuit. Our power equations use current, and we don't have it yet, so we're going to have to figure out the current. To figure out the current, we're going to have to figure out the effective resistance of this entire circuit. Now, this circuit is a little more difficult than the ones we've done up to this point because it contains both series and parallel resistors. To determine which are series and which are parallel, we think of the current running through the circuit. Conventional current leaves the positive side of the battery and has to travel through the 25 ohm resistor. But then it has a choice. It can travel either through the 11 ohm resistor or the 15 ohm resistor. After that, it all has to travel through the 35 ohm resistor. So the 15 and 11 ohm resistor are in parallel because the current has a choice. It can go through one or the other, but not both. So right now, let's concentrate on that part of the circuit. If the 15 and 11 ohm resistors are in parallel, they can be replaced by an effective resistor, and we calculate the resistance of that resistor as 1 over R effective equals 1 over R1 plus 1 over R2. Well, R1 is 15 ohms, R2 is 11 ohms, so 1 over R effective is 1 over 15 ohms plus 1 over 11 ohms. When we work that out, we find out that R effective is 6.33 ohms. That means that those two resistors can be replaced with a single resistor whose value is 6.33 ohms. Now look what we have. We have three resistors all hooked in series. Current has to travel through all three resistors, so they're hooked in series, and their effective resistance is simply the sum of the individual resistors, 25 ohms plus 6.33 ohms plus 35 ohms. That turns out to be 66 ohms. Remember, we're adding here, so we look at decimal place. Since 25 and 35 both go to the ones place, our answer can only go to the ones place. So the effective resistance is 66 ohms. Well, that's the resistance of the entire circuit. Now that we know that, we can go twinkle, twinkle, little star, voltage equals I times R. The voltage is 1.5 volts. We don't know I, but we figured out resistance, 66 ohms. When we solve for I by dividing both sides by 66 ohms, we find that it's 0.023 volts per ohm, or 0.023 amps. All right, well, that's what we need to figure out power. Power is I times V. I we just figured out, 0.023 amps. Voltage is 1.5 volts, so the power is 0.035 amp volts, or 0.035 watts.